In this video, we're going to go over practice problem number 2. So for this problem, we're going to be looking at the labor market. And of course, we're assuming that this labor market is perfectly competitive. Our labor supply is going to consist of quantity supplied equal to 10 times W, and quantity is going to measure the number of hours worked, while wage is going to measure the hourly wage, and it'll be measured in dollars. Demand for labor is given as quantity demanded equal to 240 minus 20 times W. Okay. And what we need to do is first find the equilibrium price and quantity of our labor market here. And we want to note again that quantity is measured in thousands. So to find our equilibrium price and quantity, we're going to set quantity supplied equal to quantity demanded. So we'll have 10W equal to 240 minus 20 times W. And we're going to solve for that wage. So we'll add 20 times W to both sides. That's going to give us 30W equal to 240. Next, we'll divide each side by 30. And that's going to give us an equilibrium wage of $80. Excuse me, not $80, $8. I knew that sounded wrong. Okay, $8. At that equilibrium wage, right, we want to check that we have the right one. So we want to see what is quantity supplied. So that is going to be equal to 10 times 8, which is going to be 80. And then quantity demanded will be equal to 240 minus 20 times W. And again, the wage is 8. So we have 240 minus 20 times 8, which is going to give us 160. So 240 minus 160 is going to also give us 80. So our equilibrium quantity then is 80. And since quantity is measured in thousands, we're just going to multiply that value by 1,000. And so we have that at equilibrium, workers are paid $8 per hour, and they work 80,000 hours. All right. So next, part B asks us to find the consumer and producer surplus in this market. So to do so, let's go ahead and start by drawing our market. So we're going to have that this is the labor market. The intercept for supply is in the origin, so we can go ahead and draw that in. When the wage is 0, the number of hours worked will be 240,000, so we can draw that in on our quantity axis, excuse me, and then we want to find the price or wage when no workers are hired, right? When employers don't want to hire workers for any amount of time. So if we substitute 0 for quantity and solve for the wage, we're going to get $12 as that choke price. And so we can go ahead and draw in our demand curve, all right? Then we can identify our equilibrium point that we found just now. So we have at the intersection between supply and demand an $8 equilibrium wage, and that our workers are going to be working 80,000 hours. Okay. All right. So consumer surplus in this graph is going to be the triangle under the demand curve and above the price that consumers pay. Producer surplus is going to be the area below the price that producers receive and above the supply curve. Okay, so we want to go ahead and find these values for part B. Oops. All right, so B. So for consumer surplus, that's a triangle. So we're going to use that area of a triangle formula. So we'll have consumer surplus equal to 1/2 times our base, which is the amount of labor hours hired, times the height, which is the difference between the choke price and the equilibrium price. So that's 12 minus 8. Simplifying, we're going to get 1/2 times 80 times 4. That's going to give us 1/2 times 3,200. Excuse me, not 3,200, 320. And then dividing that in 2 is going to give us 160 for our consumer surplus. And we want to keep in mind that our quantity units are measured in thousands. So we're going to multiply that by 1,000 to get our answer for consumer surplus of $160,000. Producer surplus is also a triangle, so we're going to use that area of a triangle formula, the 1/2 times base times height. And our base, again, is just the amount of labor hours hired. And then our height is the difference between the equilibrium wage and the supply choke price. So 8 minus 0. So we'll have producer surplus equal to 1/2 times 80 minus 0 times 8 minus 0. Okay, so that gives us 1/2 times 80 times 8. So we have 1/2 times 640, excuse me. And that's going to give us 320, 1/2 times 640. And then lastly, we need to multiply that result by 1,000 since our quantity units are measured in 1,000. And producer surplus here is 320,000. Okay. Now we're going to look at an intervention. So for C, we're going to assume that the federal government imposes a minimum wage of $9 per hour. Because our equilibrium wage is $8, that means that our minimum wage, new minimum wage, is going to be binding, right? It's a price floor set above the equilibrium wage. All right. So what it's going to do is it's going to move consumers up that demand curve to that $9 point, and we're going to see as a result quantity demanded fall. And suppliers, it's going to move up their supply curve, which is going to result in a higher amount of labor hours offered, so quantity supplied increasing. Okay. So part C asks us to find the value of quantity demanded and quantity supplied at the new $8 minimum wage. All right, so what we're going to do is take the supply and demand equations in turn and substitute our new wage. So demand is given by quantity demanded equal to 240 minus 20 times the wage. And for our minimum wage, that's going to be 9. So we have 240 minus 20 times 9. So that's going to be 180. And then subtracting 180 from 240, that's going to leave us with 60. And since our quantity units are measured in thousands, we're going to multiply 60 by 1,000. And so quantity demanded at $9 per hour is 60,000, down from 80,000. All right, so employers want to hire fewer people when the minimum wage goes up by $1 in this market. For our supply side, we have quantity supplied equal to, let's check what that supply equation is again, 10 times the wage. And with our minimum wage, that wage is $9. So quantity supplied is going to be equal to 90. And since quantity is measured in thousands, we're going to multiply that by 1,000 and get that at a $9 minimum wage, workers want to work 90,000 hours. All right, so what we have here, and this goes to part D, is we have a situation where quantity supplied exceeds quantity demanded. All right, 90,000 is going to exceed 60,000. All right, and so that tells us that we have what's called an excess supply. Or a shortage. Excuse me, not a shortage, a surplus. Sorry about that. It's a surplus. Don't know where my mind went just now. Okay. All right. So we have an excess supply or surplus, and to be exact, that excess supply is just the difference between the quantity supplied and the quantity demanded at the new price. So 90,000 minus 60,000, which is going to give us 30,000. Okay, so that's exactly how many labor hours are in excess supply. Part E asks us to look at the deadweight loss of that minimum wage and to solve for its value. So if we go back up to our graph, our minimum wage is going to be that difference between the amount hired under the minimum wage. In this case, it's going to be the quantity demanded of 60,000 compared to that under equilibrium, 80,000. So it's this pink triangle that I've noted on the graph, and that's our deadweight loss. Okay. So the base here is going to be the difference between equilibrium quantity in equilibrium and the quantity demanded under the minimum wage. So 80 minus 60. And then the height is just going to be the difference between that minimum wage and the price at which employees want to work 60,000 hours. Okay, so first we're going to solve for that value. So we want to say, at what wage will employees work 60,000 hours? So we substitute 60 for the quantity variable in the supply equation. Remember, supply is just quantity equal to 10 times the wage. And we're just going to solve for that wage. So we're going to divide both sides by 10, and we're going to get that at a wage of $6, people will provide 60,000 labor hours. So we can draw that in here. Okay. So our height here is just going to be 9 minus 6 for our deadweight loss. All right, now we can do that calculation. So our deadweight loss is going to be 1/2 times 80 minus 60 times 9 minus 6. That's going to get us 1/2 times 20 times 3. Half of 20 is 10, so we'll have 10 times 3, which gives us a deadweight loss of 30. And then we multiply that by 1,000, since quantity is measured in thousands, and we have a deadweight loss of $30,000. Right. Okay. So we see that there's some deadweight loss present for our minimum wage. And next, what we want to do is find the consumer and producer surplus under the minimum wage, right? And we want to compare it to their previous values. So let's go back up to our graph and identify our consumer and producer surplus with the minimum wage, okay? So remember that consumer surplus is the area below the demand curve and above the line that the price line that buyers pay. So it's this new blue smaller triangle that I've drawn. Producer surplus is the area above the supply curve and below the price that sellers receive. And so now we have a trapezoid for our producer surplus, right? And it's going to be made up of a square and a rectangle here. Okay, so we're going to solve for the areas of each of these figures. Right. So starting with consumer surplus. Consumer surplus, excuse me, is going to be the area of that triangle, a much smaller triangle, formed by the difference between the demand choke price and the $9 minimum wage, and the difference between the quantity demanded and the origin, so 0. So we have 1/2 times 12 minus 9 times 60 minus 0. This is going to give us 1/2 times 3 times 60. 1/2 of 60 is 30. So we'll have 3 times 30, which is going to give us a consumer surplus of 90. Multiply that by 1,000, since the quantity is measured by 1,000 and thousands. And we have consumer surplus of 90, right? Previously, our consumer surplus, let's see, was 160,000. So consumer surplus in equilibrium is 160,000. And under the minimum wage, it's only 90,000. So if we subtract that, then we get the amount of consumer surplus loss. In total is going to be $70,000. Part of that is going to go to deadweight loss. And then some of that is being transferred to producers, right? So let's see how producers' surplus changes in our minimum wage. Again, it's going to be the sum of the area of the square and the area of the triangle. So let's find that area of the triangle first. So we'll have 1/2 times 6 minus 0 times 60 minus 0. And that's 1/2 base times height. We'll have 1/2 times 60 minus 0 times 6 minus 0. And we're going to add to that the area of our rectangle. So that is 9 minus 6 times 60 minus 0. So plus 9 minus 6 times 60 minus 0. And then we're just going to simplify. So we'll have 1/2 times 60 times 6 plus 3 times 60. Okay, so we'll have 1/2 times 360 plus 180. 1/2 of 360 is 180. We have 180 plus 180, and that producer surplus is 360 multiplied by 1,000, since quantity is measured in thousands, and that is our new producer surplus. That is increased from producer surplus in equilibrium, which was 320, right? So producer surplus in equilibrium equals 320. So the difference here, right, from our producer surplus under minimum wage minus the producer surplus under equilibrium is $40,000. And so that is what producers gain. And so some of this is the transfer from consumers. And then you'll notice that it doesn't account for all of the loss to consumers, right? Consumers lost 70,000. This producers only gained 40,000. So the remaining 30,000 is going to be lost to deadweight loss, right? Which is what we found in Part E. Moving on to Part G. Now we're going to suppose that the government, instead of doing a minimum wage, they impose a subsidy. And that subsidy, it's a wage subsidy of $1.50 per hour. And we want to know how much labor will be demanded. So what is the quantity demanded of labor under the subsidy, and what is the quantity supplied? So in this case, we need to start with this fact that this subsidy provides or introduces a wedge between the price that sellers receive and the price that buyers pay, right? So we can represent that with an equation so that wage that sellers receive is going to be equal to the wage that consumers buy plus the subsidy. Okay. Our subsidy is again $1.50, so we can substitute that in. So the wage that sellers receive is equal to the wage that buyers pay plus $1.50, right? What we're going to do now is substitute for the wage that sellers receive in the supply equation, right? So if we have supply, remember it's quantity equal to 10 times the wage that sellers receive, and demand is equal to quantity demanded equal to 240 minus 20 times the wage that buyers pay. So with our subsidy, these wages on each side of our market are different. So in order to solve for the quantity traded, we need to find a way to find exactly what the wage that buyers pay is now. How much do they get from the benefit of the subsidy? And we also need to find what wage sellers receive, right? How much of the subsidy do they get? And so what we're going to do, like I mentioned, is substitute for the wage that sellers receive in the supply equation, and then we can set these equal and solve for the wage that buyers pay. All right, so doing this substitution, our supply equation becomes quantity supplied equal to 10 times the wage that buyers pay plus $1.50. Note that this 10 is outside the parentheses, so it's distributed across all the terms here. So we have quantity supplied equal to 10 times the wage that buyers pay plus 10 times 1.5, which is going to give us 15. Next, we're going to set quantity supplied equal to quantity demanded. That gives us 10 times the wage that buyers pay plus 15 equal to 240 minus 20. times the wage that buyers pay. All right, and now we're just solving for that wage. So we're going to add 20 times the wage that buyers pay to both sides. And we're going to subtract 15 from both sides. Okay, so that's going to give us 30 times the wage that buyers pay equal to 225. Then we'll divide both sides by 30. And that's going to give us that the wage that buyers pay is equal to $7.50. All right. Next, we need to find the wage that sellers receive. So we're going to go back to our initial relationship that we represented between the wage that buyers pay and the wage that sellers receive. And we're going to substitute for the wage that buyers pay. So we have the wage that sellers receive is equal to the wage that buyers pay, which is $7.50, plus the subsidy. So the wage that sellers receive then is going to be equal to $9. All right. All right. So now we can find the quantity demanded and the quantity supplied with this subsidy. So our quantity supplied is going to be equal to 10 times the wage that sellers receive. So we'll have quantity equal to 10 times 9, which is going to equal 90. And remember, quantity is measured in thousands. So that's actually going to be 90,000 labor hours. Quantity demanded is going to equal to 40 minus 20 times the wage that buyers pay. And we found that that wage is $7.50. So we'll have 240 minus 20 times $7.50. Simplifying, that's going to give us that our employers are going to hire 90,000 labor hours. All right, so notice that with these two different prices, right, when the price for consumers falls and the price for sellers increases with the subsidy, the quantity supplied and quantity demanded remain equal. All right, so both equal at $90,000. So if we were to go back to our labor market graph, we could draw in this subsidy to the right of our equilibrium point at that $90 mark, 90,000, excuse me, labor hours mark. To avoid making the graph too messy, I'm going to redraw it though. So we'll go up here. So we'll go below. So we'll have a labor market with a subsidy, the wage on the vertical axis, quantity on the horizontal. Our supply comes out of the origin. The choke price for demand is at $12. Remember, in equilibrium, the price of labor was $8 and the quantity traded was 80,000. And with our subsidy now, the wage that buyers, the wage that sellers receive is $9 and the wage that buyers pay is $7.50. Okay. And so we can see that with that subsidy, we have an increased amount of labor hired at a higher wage. Right. Part H asks us to find the deadweight loss of the subsidy. Okay. So deadweight loss is that portion that's produced where the costs of producing it exceed how it's valued by consumers. So this triangle that I've outlined in pink here is our deadweight loss. It's those additional 10,000 labor hours that have been hired as a result of the subsidy. And then we can find this deadweight loss by finding the area of that triangle. So we'll have 1/2 times the base, which is 90 minus 80, times the height, which is the size of the subsidy. So $9 minus $7.50, right? That'll give us 150. So we'll have 1/2 times 10 times $1.50. Okay. So 10 times 1.5 is going to give us 15. So we'll have 1/2 times 15. And that deadweight loss then is 7.5. Remember that quantity is measured in thousands, so we're going to multiply that by 1,000. So we'll have deadweight loss is actually $7,500. Part I asks us to find the consumer and producer surplus. Right, so let's identify that in the graph. Our consumer surplus is the area above the price that buyers pay, so that's $7.50, and below the demand curve. Okay, so it's this large triangle here, and that is our consumer surplus. To find that, we're just going to find the area of that triangle. So consumer surplus is going to equal 1/2 times the difference between the demand choke price and the price that buyers pay, times the amount of labor hired, which was 90,000, minus 0. Okay. So that gives us 1/2 times 4.5 times 90,000, or 90, right? We can multiply by 1,000 at the end. All right, so just simplifying, 4.5 times 90 is going to give us 405. And then 405 divided by 2 is going to get us 202.5, which when we multiply by 1,000 is going to get us 202,500 for the value of our consumer surplus. So you can see it's increased a lot relative to equilibrium as well as relative to the minimum wage. Producer surplus, similarly, is the area below the price that sellers receive and above the supply curve. So you can see here that in this case, producer surplus and consumer surplus overlap quite a bit, right? And the subsidy is what makes that possible. So if we go ahead and find producer surplus, we're finding the area of that triangle. So it'll be 1/2 times the difference between the price that sellers receive and their supply choke price, which is 0 in this case, times the amount traded, which is 90. And we just simplify. So we'll have 1/2 times 9 times 90. We'll have 1/2 times 810. So 810, right, divided by 2 is just going to give us $405. And then again, quantity is measured in thousands, so we multiply that by 1,000. And we get 405,000 as the producer surplus in this market with a subsidy. Okay. All right, so now the last thing we need to identify is the cost to the government of this policy. Right, so how much does it cost the government to subsidize, labor in this way? And so that cost to the government is just the size of the subsidy, that difference between the $9 and $150, times each labor hour hired, right? So times that 90,000. Okay, so we're just finding the area of the rectangle that I outlined previously. So the total cost to government is going to equal $9 minus $750. That gives us our $150 subsidy times 90 minus 0. Right, that gives us the 90,000 labor hours. So we have $1.50 times 90. That's going to give us a total cost of $135. And since quantity is measured in thousands, we're going to multiply that by 1,000. And that gives us the total cost to the government of the subsidy. All right. Last bit is just to ask you to think about, from an economic standpoint, if the goal of folks who advocate for both the minimum wage and the wage subsidy is to ensure that people receive a higher wage, which policy will better achieve that goal, right? More people receive a higher wage. And the answer is going to be subsidy, right? The subsidy ensures that more people receive a higher wage. Right? And why is that? Let's look at the graph. So for our subsidy graph, we're going to notice that as a result, the amount of people, labor hours hired under the subsidy increased from 80,000 to 90,000, and everybody who was working was receiving that $9 wage. Okay. Whereas if we look at the minimum wage graph, all the way back up, we can see that the amount of people hired actually falls by 20,000. And so, or not number of people, number of labor hours. So only folks who are getting that some portion of that 60,000 labor hours at the $9 wage are earning a higher wage, right? In fact, we have some unemployment, right? That difference between the 90,000 people who labor hours that people want to work and some disemployment as well, which is the difference between the 80,000 hours that people were working and now the new 60,000 that employers are willing to hire folks at the new higher price. And so more people are hired at that $9 for with the subsidy than with the minimum wage. With that concludes our going through question number 2 in the practice problems. And then the next and final video will go over question number 3.